Hi everyone, welcome back to chemistry. In this video, we're going to talk about something called Lewis diagrams for molecules. And these are really cool because we use them to represent covalent bonding in molecular substances, and they tell us a lot about our molecule. So the Lewis diagrams of these two kind of separate hydrogen atoms look like this, right? And we're familiar with those. We've been drawing them in our ionic bonding chapter. But when we want to show that electrons are being shared in a molecule, we can draw those Lewis diagrams a little differently. So we represent that sharing of electrons with a line in the middle. And that line is those two electrons. So that's kind of how we represent it. Sometimes you will see it like this, but I want you guys to start showing it like this on the right, because that's a little bit more common and can be a little bit more helpful when we start talking about the shapes of these molecules. So get in the habit of drawing it like the one on the right. But the idea here is that this line, this line that's in the middle of these two hydrogen atoms, that is representing two electrons. So it's called a single bond. And it represents two electrons being shared. So we've been looking at hydrogen a lot, but let's look at fluorine. So fluorine is another element that's diatomic, right? Meaning that it's going to bond with itself in a molecule, typically when we find it in nature. So we have our two fluorines here kind of by themselves, right? And each of those fluorines wants one more electron, right? They're just missing that one extra electron. So what they're going to do is fluorine's like, oh, well, there's another fluorine who also wants another valence electron. To get my octet, I can just bond or share these two electrons with another fluorine atom, right? So we can share these two electrons. And that's what's going to happen. So fluorine's going to come closer together with the other fluorine, and they're going to share those two electrons. And when they share, we're going to represent that sharing of electrons with just one line. You can call those that are participating in bonding, we call those bonding electrons, or sometimes bonding pairs. And then any of the ones around, and let me go blue, any of the ones around fluorine still that are not participating in bonding, because not all of them will. Some of them are just happy like they are, right? Those ones are called non-bonding pairs because they're not bonding. We also call them lone pairs because they're kind of alone. Okay, lone pairs of electrons. And now you'll notice, zooming in here, and I'm going to get rid of some of this writing here, now that you've got it in your notes. Zooming in here, you'll notice that this fluorine, when we count its electrons over here on the left, we're going to count these two, right? 2, and then 4, and then 6, and then 8, right? Because we're sharing those two in the middle. Okay, and now that fluorine has those 8 valence electrons. Notice over here, right? Same idea. We've got 2, 4, 6, and 8. So that fluorine is happy as well. So remember those kind of like Venn diagrams, right? Where you've got, cats over here and dogs over here, and then you've got, I don't know, something like tails in the middle, right? They both have tails. This is the same idea with this. You could think of it as a Venn diagram where they're sharing the things that are in the middle. What's in the middle? Electrons. Specifically, if you just have one single line here, that's 2 electrons. All right, so let's practice this a little bit. So we want to draw the Lewis diagram for the molecule HF. HF, so hydrogen bonding with fluorine. Drawing our Lewis diagrams, we've done this before, right? Hydrogen only has 1 valence electron because it's in group 1A, and fluorine has 7 because it's in group 7A, right? So we're drawing those valence electrons, and we want to show, okay, what does it look like when these share electrons? Which electrons are they going to share? Well, I'm seeing here we could draw one line in between that hydrogen and that fluorine between those two electrons that are not paired up. Okay, right? This one has a pair, so it's okay. This one has a pair, it's all right. This one has a pair, it's okay. But that last lonely electron wants to pair up with someone else, and it can, right? It can pair up with that hydrogen's electron, and when it does, we have that Lewis structure. So this is pretty far apart right now. Typically when we draw these, we're going to draw them a little closer together. Oops, sorry, I don't know what's going on with my pen here. So we draw it kind of like this. And you do want to make sure that you still show that fluorine has all of those electrons. Why don't we have any dots around hydrogen? Yeah, because hydrogen only has one valence electron, and now it's being shared. So it's being represented in that single bond there that has 2 electrons in it. And then fluorine has how many lone pairs? 3 lone pairs, okay? 3 lone pairs of electrons, right? And 1 bonding pair. So let's try this out. So this says, draw the Lewis diagram for the following diatomic molecules. You may use 2 dots or a line to represent the covalent bond. I actually just want you to do the line. And we've got chlorine. We know we're going to bond those 2 together. I'm just kind of putting them next to each other like that. Hydrogen, how many valence electrons on hydrogen? Yeah, 1. It's in group 1A, so it's got 1 valence electron. What about chlorine? Yeah, 7. 1 and 2 and 3 and 4 and 5 and 6 and 7. All right, so these are all the electrons that we can work with. We can't add any more, right? So we've got to figure out, okay, how are these going to bond so that both atoms have full valence shells, right? Remember, that's why these are doing this. That's why they're bonding. So I'm noticing we have an electron here and one here, so we could make a line between those 2, and that's what's going to happen. So let's draw that over here, and I'm just going to show it kind of in a cleaned up version, because now these 2 electrons are being shared, and that's what's creating that single bond right there. So remember, that's a single bond. 2 electrons. All right, let's try the next one. Chlorine bonding with chlorine. Remember, chlorine is one of our diatomic molecules, so we will often see chlorine bonding with itself. So how many valence electrons? We said 7, so 1 and 2 and 3 and 4 and 5 and 6 and 7. 1 and 2 and 3 and 4 and 5 and 6 and 7. And now you could have drawn those electrons in other ways, right, around your chlorine. I drew them this way because I know what this is going to look like when it bonds. You might not, right? And then you're going to just have an extra cleanup step, and that's okay. All right, so I'm noticing that these 2 electrons probably want to bond together, right? And when they do, and I'll show you why, right? When they do, we're going to have Cl bonded to Cl in a single bond. We're going to put our electrons around there. Can't forget those, right? Because chlorine doesn't want to lose any of those electrons. Okay, so this would be a good Lewis diagram or Lewis structure for Cl2. Now, why does this work? Let's zoom in a little bit. Remember, each of these want to bond together so that they can have full valence shells. For chlorine, right, that's 8, right? It wants 8 valence electrons. It's not hydrogen or helium, which only wants 2, so it wants 8. They're so close, so they can share those electrons with each other. And when they do that, this chlorine on the left has 2, 4, 6, and 8, right? That line is 2 electrons, so it's happy. And then on the right in blue, we've got 2, 4, 6, and 8, right? So that one is happy as well. So both of those have those full valence shells, and that's why they're going to bond together, okay? All right, so let's try this with an example that we're more familiar with, water. So remember, water is a covalent compound, right? It's got 2 nonmetals bonding together, hydrogen and oxygen. And it's got 3 atoms, right? 2 hydrogens and 1 oxygen. So now we kind of have to think about what might be the atom that we put in the middle. What's the central atom when we draw these Lewis diagrams or Lewis structures? In this one, right, when we look at this, do you think it's going to be hydrogen in the middle or oxygen? Yeah, it's going to be oxygen. And you'll kind of just build an intuition for this as you go along and practice this more. All right, so oxygen's in the middle, so we're going to put oxygen here, and then I'll just draw my hydrogens around it so we can pair up those electrons. So remember, hydrogen has its one little lonely valence electron. Okay, oxygen has how many? Yeah, 6. So again, I kind of know how these are going to bond, so I'm going to draw it the way that I know that they're going to bond. But you might have to do a little trial and error, and that's okay. So I've got 6 electrons around my oxygen like that. And what's going to happen is each hydrogen is going to say, well, I would really like to get another electron. And oxygen has 1 and 2 electrons that it wants to share. So this is actually perfect because hydrogen can form a bond here with oxygen. Your left hydrogen can. And then your right hydrogen can form a bond here with oxygen. And that's what we see in nature happening. So this is what that's going to look like. It's going to be cleanup step here, HOH, right? With those 2 lone pairs of electrons outside of oxygen still, right? Our lone pairs. And then we've got our single bonds here, right? With our 2 pairs of electrons each. So let's double check that these are happy. So we'll zoom in a little bit here. So hydrogen, let's look at the left hydrogen first. Hydrogen is going to have its 2 electrons, so it's happy. Look at the right hydrogen now, so we'll do that. Same idea, right? 2 electrons there, so it's happy, right? And now oxygen wants 8, so I don't know, we'll do that in purple. So we've got 2 here, right? Then 4, then 6, then 8, right? So oxygen's happy as well. Everybody's sharing electrons, everybody's happy. And that's what keeps these together in that bond. Remember, it's not like ionic bonds where we've got like a difference in charge that's keeping them together. These are staying together because they're all like, hey, if we bond together, right, and share these electrons, we can all be happy. So that's what they'll do. All right, so let me get rid of these circles here, but feel free to draw them and then just do a cleanup step. But this would be a perfect example of what I would want to see on your paper for water. For a water molecule. All right, let's practice this. So we're going to draw the Lewis diagram for the following molecules. So CH4 and NCl3. So for CH4, we've got carbon and 4 hydrogens. So which one do you think is going to go in the middle, carbon or hydrogen? Yeah, carbon, right? And if you said hydrogen, that's okay, right? You'll get used to it. But carbon, we only have 1 of them, and then we have 4 hydrogens, so we'll assume carbon's in the middle, and it is. Usually carbon likes to be in the middle of things, likes to be kind of the center of attention. So we've got my 4 hydrogens kind of around there like that. All right, now, carbon has how many valence electrons? Yeah, it's in group 4A, so it has 4 valence electrons, so we'll draw those like that. Hydrogen has 1 each, right? And now we can see, right? These are probably going to want to share. These are going to want to be shared. These are going to want to be shared. And these are going to want to be shared. So let's do a cleanup step. And we have C bonding to H there, bonding to H there, bonding to H there, and bonding to H there. Now notice, all of our electrons here are participating in bonding. So kind of cool. So how many single bonds? How many single bonds? 4 total, right? 4 total. Here's 1 and 2 and 3 and 4. And how many lone pairs? 0. Yeah, no, none, right? They're all the electrons here are participating in bonding. So these are examples of some questions that you'd probably maybe see on quizzes or exams, asking how many single bonds and how many lone pairs, just to make sure you know what those are. All right, let's try the next one. So we got N nitrogen and chlorine. We have 1 nitrogen and 3 chlorine. So what do you think is going to go in the middle? Yeah, nitrogen. And then you can just put your chlorines wherever, right? Here, here, and here's what I'm going to do. But you could have put, 1 up here, whatever you want. All right, so nitrogen has 5 valence electrons. So I'm going to go 1 and 2 and 3 and 4 and 5. Chlorine has 6, so 1, 2, 3, 4, 5, 6. Sorry, chlorine has 7. Sorry, 7. Chlorine has 7. This one also has 7 if the other one does as well. All right. Now, these, what I'm noticing, the way I've drawn it, it's somewhat obvious what's going to happen, and that's because I've drawn this a bunch of times. But again, some of this is going to take trial and error, right? You're going to draw those electrons in different spots, and it may not be so quickly noticeable that these are going to bond, and these are going to bond, and these are going to bond, right? It's just going to take some trial and error. So be patient with yourself. We'll do lots of practice. And, as always, let me know if you have questions. All right, so I'm noticing I've got these 2 lone pair, or this 1 lone pair on nitrogen, and then 3 bonds. And then for each chlorine, they're all happy. So let's just clean this up and make sure, we'll do a final cleanup step and just make sure that all of these atoms are happy, like this. All right, so zooming in here, we've got, let's look at the chlorines first. So the chlorine on the left we'll do in green, and it's got 2, 4, 6, and 8. So it's happy, right? All right, what about the one on the right? We've got 2, 4, 6, 8. Yeah, also happy, right? And then on the bottom, we've got 2, 4, 6, 8. Yeah, happy. All right, and now let's look at nitrogen. So nitrogen looks a little funky compared to what the other atoms we've been working with so far. So let's just double check that it's happy. So it does have this lone pair up here. So it's, I didn't mean to do that, sorry. So it does have, let's go black, I guess. It does have this lone pair up here. And then it's also got these 2 that it's sharing with the left chlorine. So that's 2 and 4 so far. Now it's got 6 here because it's sharing with this other chlorine. And then 8, right? So also happy. There's a lot going on here, but just kind of take it step by step. Is my left chlorine happy? Is my right chlorine happy? Is my bottom chlorine happy? Is my middle atom happy, right? And what do I mean by happy? Remember, 8 valence electrons, right? Unless you're hydrogen or helium, and in which case you want 2. All right, so let's get rid of this stuff here so we can see this better. And this would be a good final answer for the Lewis diagram or Lewis structure of NCl3. But double and triple bonds can also happen. So if a single bond is 1 line, right? That's a single bond. A double bond is 2 lines. And a triple bond is 3 lines. Oops. Triple bond. Actually, let's write this like this. Single bond. All right, now, if a single bond has 2 electrons, what do you think a double bond has? Yeah, 4, right? Because there's 2 in this one here and 2 here. All right, what about a triple bond? Yeah, 6. Oops, 6 electrons. Right? Because 2 here, 2 here, and 2 here. 2, 4, 6. So 6 total electrons in a triple bond. So let's look at an example of why these form, because I think it's easier to explain with an example. So oxygen, right? Oxygen is one of our Hofbrinkels. It's one of our diatomic molecules. So when oxygen's found in the atmosphere, we usually find it as O2. It's bonded to itself. So let's take a look at this. So we've got oxygen and bonding to another oxygen. And both of those are going to have 6 valence electrons. So we got 1 and 2 and 3 and 4 and 5 and 6. 1 and 2 and 3 and 4 and 5 and 6. All right, now with oxygen, notice that each oxygen wants to share 2 more electrons because they want 8 and they've got 6. So instead, it doesn't work, right, if oxygen just shares with a single bond. Because now look at this, right? On the left side, we've got 2, 4, 5, 6, 7. That's not right, right? And then on the right side, we've got 2, 4, 5, 6, and 7. That's not the right amount, right? They want more than that. So what they'll do is they'll make a double bond. So they'll share 2 pairs of electrons. And then, now on the left, we've got 2, 4, 6 from this top line, right? And 8 from the bottom line, right? 2, 4, 6, 8 total for this oxygen. Kind of a weird circle there. And then for the other oxygen, right? 2, 4, 6, and 8. Okay, and that's a way for those oxygens to achieve their octet. But they can only do that if they form a double bond, because you don't want to have these kind of lone electrons. That's really unstable. Those are called free radicals. You might have heard of those. All right, so what we're going to do is we're going to form, a double bond. Double bond, okay? You wouldn't call this 2 single bonds, okay? This is a double bond. And it has 4 electrons being shared. So let's do our cleanup step so we can see this a little bit better. 1, 2, 3, 4. Boom, boom. 1, 2, 3, 4. All right, so that's an example of a double bond. Triple bonds can also form, okay? And we'll do lots of practice with this, and you'll get some, you'll understand why triple bonds might need to form. A lot of this is kind of like puzzle solving. So your overall goal for the puzzle is to get every atom to have a full valence shell. And sometimes that takes, 1 double bond and 2 single bonds, or 1 single bond and 1 double bond, or 2 double bonds, right? It just depends. And you'll see kind of what I mean by that in the future. Okay. All right, so let's do another example here. And this time we'll have CO2. So we're going to try to draw the Lewis structure for CO2. So what do you think is in the middle, carbon or oxygen? Yeah, carbon. So we'll just do, carbon in the middle because we only have one of them, and then our oxygens can just go, I don't know, around there like that. That looks good. So how many valence electrons for oxygen? Yeah, 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. All right, what about for carbon? Yeah, 4. 1 and 2 and 3 and 4. All right, so what if we draw a bond here and here to connect our atoms? Well, I'm noticing, right, oxygen on the left here has 2, 4, 5, and 6 and 7. So 7. So that's not right, right? So already I'm noticing that might be an issue. On the right here, again, 7, right, around the right oxygen. And then carbon's also really not happy. Carbon's got 2 and 4 and 5 and 6. So it's missing 2 electrons, right? So how are we going to remedy this? What can we do? We can bond these 2 here, okay? And now let's see. We've got, on this oxygen, that oxygen is now happy, right? Because it's got 2, 4, 6, and 8. What about the left oxygen, though? Yeah, still not happy. And then what about carbon? Yeah, not happy either, right? Okay, so we got to keep moving along here. So we got to figure out what can we do. So let's go, we'll go in, I don't know, green. We'll go green. So notice, right, we've got this electron and this electron here. So we can make another bond between those 2. And, this is why I always do a cleanup step, because this looks really weird right now. We're not going to draw our double bond like that on the left. So let's clean this up. It looks like we've got 1 double bond on the left and 1 on the right. So we'll go oxygen, double bonded to carbon, which is double bonded to the other oxygen. And then we've got 1 and 2 and 3 and 4, 1 and 2 and 3 and 4. Okay, so let's double check that everyone's happy. So this oxygen on the left, we've got 2, 4, 6, and 8 in that double bond. Looks great. What about on the right? 2 and 4 and 6 and 8 on the right. Looks great. And then carbon in the middle has 2 and 4 and 6 and 8. Bam. All happy. Awesome. So notice with this, we had to have 2 double bonds. Okay. And sometimes that happens. Sometimes you'll even need a triple bond, right? There's no way to draw this Lewis structure with just single bonds and have all of your atoms be happy. Okay. So again, kind of like a little bit of puzzle solving here. Some people really like it. All right, let's try this out now. So we've got hydrogen with carbon and nitrogen. Again, carbon really likes to be in the middle, and that's just something that you'll get used to. So we'll put carbon in the middle. And then we've got hydrogen and nitrogen, and I'm just going to put them like that. So we've got hydrogen has 1 valence electron, carbon has 4, and nitrogen has 5. All right, now let's see. What can we do? We can draw 1 single bond between that hydrogen and that carbon. And that makes hydrogen happy. What about the nitrogen over here? I'm noticing we could draw a bond there, right? But that leaves carbon unhappy and nitrogen also unhappy. So what can we do? Well, we can draw another bond here, right? Make a double bond, but we still aren't happy, you know? We've got this and we've got this, and yeah, it's kind of a mess. So how many do we have on nitrogen? We have 2, 4, 6, 7 on nitrogen. So nitrogen wants 1 more. And then carbon has 2, 4, 6, and 7. So it also wants 1 more. We can actually, I'm noticing I have an extra electron here and 1 here. So what if we made a bond between those? Okay, so I know, it looks really weird. So we got to do a cleanup step. We're going to leave those lone pairs alone. So we got hydrogen bonded to carbon, triple bonded to nitrogen. And I'm going to put the electrons over here. That's just the convention. Just get them as far away from that triple bond as possible, because there's lots of negative charges here, and these are negative as well. So they actually want to get as far apart as they can. And then, so this looks good, but let's just double check. So hydrogen bonded to carbon has its 2 electrons, so it's happy. Carbon has 2, 4, 6, 8, so it's happy. And nitrogen has 2, 4, 6, 8, so it's also happy. Okay, so this would be how you would draw the Lewis structure or Lewis diagram for that molecule. Again, for this next one, carbon likes to be in the middle, so I'm going to put carbon in the middle. And then I see I've got 2 hydrogens and 1 oxygen. So I don't know, I guess I'll put a hydrogen here, a hydrogen here, and an oxygen here. And let's just see if we can make that work. All right, so carbon has 4 valence electrons, 1, 2, 3, 4. Hydrogen has 1 each. Oxygen has 6, 1, 2, 3, 4, 5, and 6. All right, so let's see, we've got, well, let's just go ahead and bond these hydrogens, because we know they're going to form these kind of single bonds typically, right? Because they only need 1 more electron. So both of those hydrogens are happy. And then let's see, oxygen over here. Well, I'm noticing I've got these 2 we can bond together. And then it looks like maybe even like a double bond. And let's just see if that works. So let's get our cleanup here. So we got CO, H and H. And let's double check. So this hydrogen's happy. This hydrogen's happy. Oxygen has 2, 4, 6, 8 happy. And then carbon has 2, 4, 6, and 8 happy. Awesome. So this looks pretty good. Again, right? If you didn't like immediately see that there was a double bond there, that's okay. You can play around with it until you get the right number of electrons for everybody. Okay. What you can't do is ever add electrons or subtract them. What you have, the total electrons that are on your paper are the total that you have to work with. And now you have to arrange where they go. Okay. So this would be the Lewis diagram or Lewis structure for this molecule. All right. There are several other ways methods to get to these answers, right? To get to these Lewis diagrams. Your book has another helpful method. I have found that students usually like this method better that I've shown, and that's why I decided to explain it this way. But there are lots and lots of other ways. So I'd encourage you to read your textbook and see if you like that method better, and you are welcome to use that method to draw the Lewis diagram. I can also show you it if you think you'd like it better. We can do some examples in office hours. Just let me know. And that's it for this video. I'll see you in the next one.